The graphs of f of x and g of x are shown below. In part A, determine the polynomial corresponding to f of x. F of x is a cubic polynomial with zeros of -1 with the multiplicity of 1 and 2 with the multiplicity of 2. We can set up the template polynomial p of x equals a times x plus 1 times x minus 2 squared. We know 3, 8 exists on the graph. Plug in 3 for x and 8 for p of x. This gives us 8 equals a times 3 plus 1 times 3 minus 2 squared. Simplify to get 8 equals a times 4 times 1 squared. This gives us 8 equals 4a. Divide both sides by 4 to get a equals 2. The polynomial function is f of x equals 2 times x plus 1 times x minus 2 squared. Now we'll move on to part B. Determine the equation of the line corresponding to g of x. Recall that the equation of a line can be found using y equals mx plus b, where m is the slope of the line and 0b is the y-intercept. Bring back the graph and the equation for f of x that we found in part A. The formula for slope is rise over run. The rise is 1 and the run is 1. The y-intercept occurs at 0, 1. The slope-intercept form of a line is y equals mx plus b. Plug in the slope and b value to get y equals x plus 1. Replace y with g of x to get g of x equals x plus 1, since we need to express this using function notation. In part C, determine q of x equals f of x divided by g of x and draw the graph of q of x. Let's bring back the graph along with the equations for f of x and g of x that we found in parts A and B. We want to find the quotient of f of x and g of x. Replace f of x with 2 times x plus 1 times x minus 2 squared, and replace g of x with x plus 1. Cancel out x plus 1 in the numerator and denominator. The quotient is 2 times x minus 2 squared. We have the restriction that x cannot equal -1, since q of x originally had x plus 1 in the denominator. The graph of q of x equals 2 times x minus 2 squared is drawn in red.